Hey everyone, welcome to the second episode of Make It Better. And today's guest, I'm looking at the comments already. Everyone is excited for the person we're going to bring on. It's someone that I go back a couple decades with now at this point. Todd Blacksher from Metalworks. Todd, how are you doing today?
Really good, really good. How are you?
Not too bad. So, Todd, why don't you tell the people, like maybe the two or three people outside of the SolidWorks ecosystem that don't know who you are, what you do, where you work, what it is that Metalworks does?
Okay. I'm Todd Blacksher. I'm from Lincoln, Nebraska. I work for Metalworks. We're a contract manufacturer, and we do pretty much all things metal. Um, Laser cutting, forming, punching, machining, powder coating, you name it, that's what we're doing.
Okay, that's a good intro. That's a good intro. You're located here in Nebraska with me, down the road here, not too far away, right? You and I used to be colleagues once upon a time. Worked
Back
at a
in the bar
reseller,
days.
and we were talking. I think it actually goes back to we first met at Duncan when I was working to train and onboard everyone at Duncan, right?
I believe so, and that's a few years back.
There was a lot less gray hair, maybe a few pounds less back then. But the reason we're having you on today is because our discussion is more talking about making it better and designing products. And you mentioned you do a lot with anything metal and the progression for that. So let's talk a little bit about what your job is at Metalworks and what your group does to make those products successful.
Okay. So I'm part of the QRM team, which is Quick Response Manufacturing, and we do a number of things. One of those is basically getting product through the building as fast as possible, as efficient and accurate. Since we are a contract manufacturer, we're seeing finished designs. And so our role is, do we need a form gauge that we can set up at the press break so they can do a quick quality check? Do we need a weld fixture? Do we need specialized assembly tools? Things like that are just one of the arms of what the QRM department does. We're also doing a little bit with rapid prototyping as far as if a customer wants to test out a new product, we'll kind of scoot them through really quick. Instead of going through the normal production, it'll go through our department. And then the third aspect, we are trying to basically keep production running at full capacity by pulling out some of the stuff that might interrupt the flow and taking on that role ourselves. So we would be taking those parts and making them so that production can keep running the high volume stuff that they need to be focused on.
Okay. So how does you mentioned a couple different projects, a couple different avenues. So how does a project come to you? Like, how's that prepared?
Okay. Basically, like I said, since we're a contract manufacturer, the job will come in, and ideally when we're quoting it, we'll take a look at it and see what tools we will need as far as what is it going to take us to make this product. Like I said, the form gauges, the weld fixtures, we like to have those going as early in the role as possible. So we're going to look at that hopefully in the quoting stage, but if not, the job comes in, that's when we start looking at it. And our team has a number of people that, we all have our strengths, but we're all cross-trained. So the QRM director is basically going to bring it out and go, okay, hand out the jobs, you're going to take care of this. But we all work together and, constantly asking each other questions as far as, hey, I need a little bit of help with this. You've done something with this. Once the order comes in, we're off to the races doing what we need to do to make it happen.
Okay. And so generally a lot of these stuff that you guys are doing, because it's quick response, I assume you guys take the shortest path to meet the product with the best quality you can for whatever the short run delivery time is, right?
Right. And, on the long-term jobs as well, the big runs, those we want them to be able to check the parts as easily as possible. I've done a lot of 3D printed devices to hold parts in the for the ferro arm to be able to check it. They can just drop in a part, magnet holds it in place. They can scan it, know that it's accurate. So it's everything from up front to the tail end before it goes out, just making sure that it's accurate and efficient. Specialized assembly tooling, put things together.
Okay. So what design processes do you use? Because you talked about doing fixtures and gauges and things, and that's a pretty big group, right? So what design processes do you use when you try to solve these problems? Because I assume it's not cookie cutter, one and done type thing.
No, there will be some families of parts that are similar where they're just scaled up, they're different sizes. And that's where we can do a little bit more flexibility with our fixtures, maybe by setting in pins to where they can quickly adjust it. But a lot of it is one-off, unique type stuff. And so that's when we're, modeling it up in SolidWorks. We're making a fixture, say it's a weld fixture. We need to put in the clamps, how we're going to clamp up the part. Basically make sure that the part will come out of the weld fixture when it's done. I don't know, a lot of different things. I don't know. I guess, and there's a lot of working together, I should say, as far as you've done something like this. I've got this new one. How did you hold that part in place? Oh, I used the specialized clamp. So, and there's a lot of working with the shops, because if there's something that I'm struggling with, first place I go is out to the shop and I'm like, hey guys, we need to hold this in place to weld it together. Here's what I was thinking. If I do that, is it going to interrupt things? Is it going to cause a problem? Or forming. I call them at least a couple times a week. Like, I've got this part that I want to use on this. Is this going to work? And that's when I run into the things like, oh yeah, we can do that. We're just going to have to do this, that, and the other. And I'm like, okay, you can do it once or twice, but what if this is a 5,000 part job? I don't want you to go through all that every time you set up. So let's work together and come up with something that's going to be really easy for you, but it's going to get the most accurate part possible.
Yeah, and before I respond to that, because you've mentioned a lot of things that I want to dig into there. This is live. If you guys have questions for Todd, the man in glasses, as was put in the comments there, feel free to jump in and ask some questions for Todd. But you mentioned a couple of things about designing fixtures and tooling, and in a previous life, I did a lot of those, and it really comes down to there's a lot of knowledge that you have to have as far as shrinking and warpage, and making sure that sometimes we over clamp a part, so when we weld it, it comes back within the spec. And at Metalworks, you guys have several facilities around the Lincoln area, so I imagine being overly communicating to the team in the shop and getting feedback from them is probably key for Metalworks success, right?
That's the way that I work. I mean, I am the over communicator. I don't want them to end up with some nightmare project because I didn't ask about it. And that's why even in the early stages, I like to go out and actually, talk to them or show them what I have. I just did a hand bend fixture last week where we have a part that most of the bends are done on the machine, but there's a couple less critical bends that they have, basically tears in the slots so that they can hand bend it. And I 3D printed a tool, but I also made a welded fixture that they can drop the part on, clamp it in place, use the 3D printed tool to reach in and make the hand bends and give them a nice crisp edge. And that was one that, even when it was rough sketches in SolidWorks, I printed it out, took it out to the shop and said, this is what I'm thinking. And luckily he said, that's almost exactly what I had in mind. I just couldn't draw it up. So communication is key on all of this stuff. Just, hey, if you weld this, are you running downhill? Are we going to have draw? What's going to happen? Because I don't know all that. And that's where I really rely heavily on my team to give me the feedback to make the best product for them.
Well, and you and I are of a certain era where I think our ego has sort of left the room a long time ago, right? And I think some of the challenges that I've seen between engineering and manufacturing and making good parts has to do with the ego. And it sounds like, and from my experience being around Metalworks, you guys have done a really good job of creating a culture to where you can openly have those conversations.
And that's one of those things that I found a long time ago. You will learn more about sheet metal from talking to a grumpy press brake operator than you will from any teacher, because they are going to be just flat out and truthful with you. And that's really what got me to go out and start asking the questions like, I don't think this is going to work. Is there a way that this can work? Or do you have a better suggestion? And as soon as you start to develop those relationships, people understand that you want their input, and then they're more likely to give it to you rather than them getting a bad part and going, oh, they messed it up again. They feel the power to call you and say, hey, this isn't working right. What can we do to make this work better? And when you respond,
I agree with that. My sheet metal schooling started at Benson Machine Works, so obviously I was immersed with the grumpy press brake operators, which is probably why I have that resemblance of being grumpy all the time when it comes to sheet metal and things like that, because you just sort of inherit the people's personality that you learn from, right? So,
yeah.
So when we talk about these, it sounds like whether it's one part or 5,000 parts, it's a matter of speed and accuracy, right? To meet the customer's deadline. To the more things you can get through, then you can grow a bigger customer base, and you can do all of those good things. So how do you guys take the methodology of I can do it a million different ways? How do I design as efficiently as possible to meet those deadlines? Because as we all know, as engineers, there's a million ways to do things. And a lot of times engineers get stuck with paralysis of, I don't want to commit. So how do you guys design as efficiently as possible?
The nice thing about that is, most of the stuff's coming to us already designed. So our design part is the fixtures, the check gauges, the various tools that'll go with it. And a lot of that comes from what we've done over the years, what we've found works. And one of the biggest ones is being able to get the part in and out of the fixture as quickly as possible. And then we factor in the whole robot factor. If we want to put this on the robot, how are we going to hold it in place on the robot itself? And so there's a lot of variables, and a lot of it just comes from building on what we've done in the past and not being afraid to try new things. There have been a few that I've looked at and it's like, well, we've done it that way, but have we tried this? And a lot of times there is, yeah, we've tried that and it didn't work, so we didn't do it. It's like, okay, I asked, I got an answer, and I moved on.
Okay. So let's, you mentioned 3D printing a couple of times. So let's dig a little bit deeper into that, because it's been a few days since I've designed weldments and I've designed fixtures for weldments and things, almost a decade now. So how have you went through the process of going into adopting additive? How do you know the right time to incorporate additive into a fixture versus doing it in a traditional method? Like what's your boundaries that you use when you design to make a fixture to make the parts, come out better while reducing the overhead cost of a fixture design?
A lot of it with, additive manufacturing is like, if it's going to be on a weld fixture, is it going to be in a place where it could melt? A lot of times we're just using that to cover or attach like air cylinders or different grabbers that are away from the heat. We just started incorporating them more for assembly tools, something quick and easy that they can grab that does a specific purpose. We've also done, I mentioned the QC fixtures. Those were really nice because it was a very swoopy part that they needed to measure. And so I was able to create that shape in SolidWorks, print it out, and then have a couple pockets for little neodymium magnets. So that way, when they went, the part would just drop in and lock into the perfect place for it to be scanned. We've also done, well, and one of the big places that we've gone with additive is end of arm tooling for our robots. Some of them, we have it just so that it holds a suction cup because it's air to pick up the part, or a magnet. On the air ones, we'll have, very simple ones that have a suction cup to pick up the part, hold it on the press brake, comes down, makes the bend. And some of them actually have, I just call it a scooper, but it sweeps the part off, drops the next one in, press brake comes down, it goes and picks up another one. This is done, sweeps it off, drops the next one. And then when we started to get to larger stuff, we started to incorporate the air lines inside the printed part so that we didn't have all the tubing and junctions and everything on the part. We just screw the suction cups into the 3D printed part. We plug the air hose into the junction that's screwed into the 3D printed part, and everything happens inside the part. I just printed the airways in there, and that makes for a quick setup and extremely clean because you don't have all the airlines flopping around.
Okay, we'll get to robots here in a little bit. There's a couple other things I want to ask. Sean, I got a question from Sean here, but I first want to, you said something, I want to pick up on that before we go to Sean's question.
Okay.
So when you talked about creating fixtures and test, with the magnets and components to slide it into place, how are you doing your design to compensate for tolerances? Are the parts you're doing for check fixtures, are they super tight tolerances like ±1? Or are you in a little bit wider range? Like, how are you designing for that check on parts where they need to snap in and fit?
A lot of those are more wide range because the snap in and fit, those parts we were looking for a specific area of it, and we were checking it with the ferro arm. So we just needed to hold it in the same place every time. So what happened is we just wanted that part to sit on the, marble slab for the ferro arm in the same place. And that was the only reason we did that, because the part, the printed part itself, it just had to touch off in a few key points and hold it because what was being measured was kind of out at the end of the part.
Okay.
And it was a ferro. So we're just doing a scan of it. So it's not like we were no go gauging it with a printed part.
Okay. So more of it was to create like a zero reference to where everything's measured the same. So then the ferro has a reference point from that zero. So you're basically setting up a work offset to where it's always going to be in one spot. And then everything that we need to check that's critical is going to be quickly to adjust from that one position.
Exactly.
Okay. So now we'll get to Sean's question. So do you or Metalworks have any thoughts on how AI might figure into how you do things, part making, manufacturing processes, automation?
I don't believe that. I haven't been involved in any of the discussions. They may have. If I were to hazard a guess, I would, it's hard to say because we're not designing the parts, but I could see it doing some of the tooling or robotic controls. Because I could see if you have a family of parts that gets formed a certain way, I could see your forming robot being set up to, possibly adjust. Like, okay, this part's a little bit bigger. And once you are teaching it, if it knows the amount to change, I could see something like that happening. Because there are a lot of parts that we run that are just a little bit different. I mean, everybody that designs the parts knows that because that's how they're designing them. It's like, well, it's like that, but 5/8 more. So on our end of things, I could see the press brake program being set up that way. So once we start teaching them, then we could see the differences and then have it hopefully create its own code for the next time around, where you could just give it some information and go, oh, it's just like this one, but here's the difference, and have it make the adjustments. I think that'd be great.
Yeah. Hey, well, and I'm going to answer one question, and then I'm going to share my personal thoughts, Mike Buckley's thoughts. So I'm clarifying that so I don't get in trouble. The question is, will this be saved for later? Yes, it will be available on live.solidworks.com. Anybody can go back and watch this after, so feel free to share it with whomever after the episode's aired. Here's what I see, and I spend way too much time going down rabbit holes watching other people's marketing and positioning and pitching, and I'm the grumpy old press brake operator, so bear in mind that before I give my answer. I believe right now there is a lot of confusion between automation and AI. And there is a lot of marketing done for things that are automated that are not AI. I've seen a lot of things recently for machining and robot programming where it's like, oh, look, I take this template, I upload it to the cloud, and then I run this part and it's AI. Well, that's not AI. That's automation because I'm running against a set of rules that are templates. AI is I have this pool of information that exists about how I do my things internally, and it's intelligently looking at the past 30, 40, 50 things and then giving me a solution based on that. It's not I take a template and then it does X, right? And I think the other thing to phrase that is like in our robot programming, and we'll talk about robots here in a little bit, Todd, we've added in 25X, we added palletizing. So now I can drop in a conveyor, I can drop in a pallet, and our software will automatically determine how many packages or boxes will fit on that pallet based upon weight, layer, slip. And then it'll automatically create the program to tell the conveyor when to stop, to pick it up, place it. Those things are more AI because I'm picking a conveyor and I'm picking a pallet and it's figuring out the trajectory before it. I think in manufacturing, there's a lot of automated template companies selling AI, and that's not truly what AI is.
Yeah, I agree with that, because that's, automation is basically laying your groundwork and what it should do. So yeah, I'm glad you said that, because I hadn't really thought about it that way.
Yeah, I mean, you and I go back into SolidWorks CAM and CamWorks all the way back to 1998, and they had automation through templatizing. And we see lots of companies now selling templatized things as AI, not the same thing. So that's a Mike Buckley perspective, but that's also the R&D person in me. If I can create a template and just have it repeat a series of processes off a template, that's no different than automated programming for anything else you see in this world, right? Like my camera on my computer, if I hold up my hand the right way, it'll auto start tracking me. That's an algorithm that's just centering on the frame of my mug that's moving however. AI would be as soon as I log into a live stream, everything turns on and all the settings automatically map from the bandwidth that I have for that day. That's taking history and applying it to the future. So I'll step off the grumpy old press brake operator soapbox, but to me, like when we talk about AI, it gets misused a lot. There is a question though that I do think comes into play, which is thoughts on GD&T for AI. And I think there might be something for that. So you have thoughts on that for GD&T?
We don't actually use much GD&T. That is one of those ones that to me really lies in the hands of the designer, because they're the ones that truly know their design intent and their requirements. And it would take a lot of training for AI to be able to magically predict, like, oh, well, it's more important to have this hole concentric than this hole, or this dimension can have this much leeway, but not this one. It would take so much to teach it that, whereas the person actually designing it knows what they're after, hopefully.
Well, That's a whole nother episode, Todd. Do people know how to do GD&T the correct way with stack up tolerance, or they just do put ±1 on everything and hope that someone figures out how to make the part the correct way?
Yeah.
That's a whole other thing.
Plus or
Um,
one for Mars, +or -2 for Jupiter.
yeah, yeah. I mean, there are people that just fly around the company or fly around the country that just help large companies figure out the best practice for GD&T for a given product, which tells me that most people have no idea how GD&T works. So with that, so Sean replied, I also feel like AI is only interesting to select individuals. Many people I speak to only seem to care about the task job that is done well, efficient enough. 10 to 20% is better. What are your thoughts on that? I have thoughts on that.
um, I kind of get the feeling that people are rushing into AI like it's the next big thing because that's what they've been told, that it's the next big thing. And I think if people would start working smarter, they wouldn't be leaning so heavily on that because there's so much that we can do and maybe use AI to help with it. But I think we need to be leading that.
Yeah. Yeah, I agree. There's a lot of people that are, it's like the Flex Seal meme or GIF, right? Just slap the sticker on the side of the water tank that's leaking, and now I got AI. I think what most people don't get, and there was actually something that came out a couple weeks ago where they were talking about it that was interesting, where for AI to actually work, you first have to have a virtualized environment of everything that you do. Second, you have to have the data pool to pull from to be accurate to make the right decisions. So having AI, but not having the virtualized twin of that means that you don't have the full scope of everything. Let's take robot programming or CNC machining. If I don't have a true, accurate, virtualized representation of those things, full kinematics, full motion, full reach, I can never use AI to tell me how to do that successfully because I haven't put in all the parameters. The second thing with AI is I have to have a large enough data pool of information to make the right decision. I can't take one thing and say, this is how I'm going to do it forever. AI has to be predictive and learning. So when you start talking about those things, step one, which most people don't want to do, is build the accurate virtualized environment of whatever it is I want to automate, whether that's machining or robots or plant or design and CAD. You have to first have those pieces.
And that's the foundation. I mean, it's like building a house. You don't start at the roof, you start at the foundation, and you need to get that built and established before you can start putting stuff on top of it.
Exactly.
Until you get that.
Yeah. So yeah, I agree. That's where AI gets confusing because everyone's like, oh, hey, here's the easy button. Now we have AI. Okay, well, what's it pulling from? How's it working? How are we setting up my exact environment, right?
Yeah.
And I think on that note, we can now transition a little bit in robotics. So one of the things you've been working with us on for last year, trial, testing, implementing, is Robot Programmer Standard, right?
Mm-hmm.
And you at Metalworks, you guys have quite a few robots. You want to talk about those? Then we'll talk a little bit about the journey of what you guys have been trialing and testing.
Yeah. So, like in our forming facility, we have 7 robots. In our welding facility, I think there's probably around 18, maybe more. Oh, maybe a little bit less because I think we have them spread out over 3 buildings. And I believe that at last count, we were up to 27 or 28 robots. And, there's robotic cells, and some of them have, most are single robots, some have 2. I believe we have one that has 3 robots. And it ranges. So we have some at forming that are basically tending the press brakes. They're picking up the flat piece, pulling it over to the press brake, going through all the bends, taking it off, putting it on the pallet, and then grabbing the next one and repeat. And that's really nice because if you've seen the size of some of the parts that we do, I would not want to lift those. So I'm really glad that this robot's picking up the heavy stuff. And then we have robots doing welding where it's just an extensive amount of welding on these large parts. And basically, I mean, some of them are on turntables, some of them are on, you know, flips. We load up the parts, clamp them in place. Robot comes in, hits all the welds, pull them off. And then we also, those are the main ones, but like, and I guess the best example here, because I know that a lot of people are like, oh, you know, robots are taking jobs, robots are taking jobs. They're not. I view it as, number one, I don't want to lift that really heavy part. And if I don't want to do it, I don't want my teammates to have to do it. But we had a job where a customer wanted to ramp up their output. They said, okay, you know, starting at this time, we need to get this many more parts from you. And that's where we worked with them and said, okay, in order to do that, we're probably going to have to get this on robot, and we're going to have to possibly make a few tweaks to the part. So we worked with them, made a few minor tweaks just to kind of help the parts fit together and almost self-fixture. And by the time everything was said and done, we were able to double our output with a third of the people. And to me, the big benefit of that is we had some really good welders on that line. Now they're able to do other stuff, because I always look at it through my eyes, like, would I want to weld the same thing every day, day in, day out? And, you know, these are some parts that have a lot of critical welding. And so we would put some of our best on it, and they would be doing those same welds every day. Now we're able to put some people to tend that cell with the robots, and those people are doing different welding, and they're able to dip into different things. And so they get a little bit more variety, and they're not stuck on that.
Well, I think it's also a generational thing, right? Back in the day, there were people that would come work in a factory and all they wanted to do was that one thing.
Yeah.
In today's world, it doesn't really behave that way, right? People want to do other things. They want to be challenged. And to your point, most people don't want to kill themselves lifting up heavy things that can now be done in smarter ways. So as we start talking about Robot Programmer Standard, can we talk a little bit about the process that you guys have been through in the last year, one of the examples that you guys went through, and then, you know, the more pointed question of how has robot programming helped you design better fixtures and validate issues in the last year that you guys have been trialing it?
Okay, I've got a couple of parts here, so I'm going to kind of bounce around a little bit.
Okay.
As far as designing fixtures, and this is something that I think that it breaks down a number of different ways. Say you have a welded fixture that you're going to use, and you have a number of pieces that are going to be welded together. You have one designer that's going to model it all up, design it, and send it over, not worry about how it's going to get welded. Don't be that guy. The next one is going to look at it and go, oh, there might be an issue here. I might talk to someone out in the shop to see if it's going to be an issue. Another person might bring in a weld arm and put it in their part or their assembly and be able to kind of move it around and see if it's going to interfere. That also helps, but those are usually loose. Now, if you take said weld fixture, you drop it into the robot programmer, then that weld arm is connected to the robot, and you can move the robot through its motions and make sure that it's going to come in, and you can adjust the angle and make sure that it's going to hit all the parts that it needs to. And you'll know for a fact that it can, instead of like just the loose one inside the SolidWorks model, because it's not connected to anything, and it might hit a position that the robot can't hit. So the other side of that, that's welding. But if you look at the forming side, the video that showed when I was talking at World was of a part that we made that was mirrored, and it's not a true mirrored part because the way it's set up, but it looks like it. So basically it being on a robot, it has to hold it in a certain way when it's grabbing and releasing from the press brake. The mirror part flips over. Well, now instead of grabbing it from this side, the robot's coming around and grabbing it from this side. And I was able to tell just as I was moving things around that we would need to adjust the tooling in the press brake in order to reach that bend. And that was a big thing for me, like right up front, before we even did anything. I said, hey, you're going to have to shift that tooling over 2 spots, or we're not going to be able to reach it the way it's set up for the opposite version, the mirrored version.
Well, and there's a question we'll get to in a second, but I do want to bring up something you said there, because a lot of people are like, oh, well, I just go download XYZ robot and I put it in SolidWorks and I put mates on it and I can just do it there. Can you sort of explain the difference? Because me playing with the software, I obviously know the difference, but can you articulate the difference between using a robot programming tool and using SolidWorks to figure out what that position is?
For me, I just boil it down to the really easy. The robot in the programmer is accurate, and it is tied in with what that robot is capable of. I can grab a 3D connection controller and move it through its motions, or I can grab the robot and joint 1, joint 2, joint 3, and move those. And if I run into a singularity, it's going to tell me. A lot of times, I've seen people download some robots, but usually I just see them with a short weld end of arm, just the weld bit, and they'll use that. But if you bring in the robot, you're going to have mixed results with a SolidWorks model versus something that is in there and you're able to move it through the true motions of that robot. And while you're doing that, you're basically creating the program, and then you can just kick it out to the robot.
Yeah,
it's kind of a roundabout way to get there.
Well, it's the true kinematics, right? Like
Yeah.
It's only going to move in the joint positions that it's allowed to move. You're going to see the over travel. You're going to see the reach. You're going to get the tactile feedback that I'm now hitting singularity, and we don't ever want to be in singularity with robots, right? Yeah. So although I can use this tool, just like I can use a flat blade screwdriver as a chisel, it's probably not the right tool for the right job, right? And that's really the crux of it, I guess, from like my experience working with it and the things that go with that. I do want to jump back to this question here quick though,
because go for it.
From a student. So it says, for an undergraduate engineer who wants to work in the design and manufacturing field, is it worth it to start learning about GD&T? Is it important of a skill set that I should be equipped with? What do you think?
I say yes. And I put a lot of hopes and dreams on our students because a lot of times the students, and I see it from the ones coming out of SCC, but they are the ones that are going to push industry into the next level. We need that young blood with the new ideas and everything to start to push this giant ship that's been doing things a certain way for so long into a new direction. And I think we need students to express GD&T. We should be doing this. It actually gives the machinist a bigger tolerance. It makes this happen. It makes this easier. And the more we can have students pushing the industry, the better we're all going to be. I mean, I like I said, I put a lot of hope and weight on the students, but they are going to be the change makers. They're going to be the ones that push us to the next level, and we really need that.
Well, I think it's important to know GD&T. I think it's also as equally important to know how to build something to GD&T. I think the thing that gets missed is the hands-on portion. So like if you get a new grad that's always taken everything without ever building anything, so they know all the theory of how it works, those are the prints you generally see that are over toleranced or there's no tolerance. And then you come back and you build it and it's like, well, it doesn't fit. Well, yeah, you didn't give me the right recipe to make it work, right? So I think the understanding of how GD&T actually works and functions is the key with all of that. Because just knowing GD&T is only 80% of what you should know, you know?
Well, and one of my big bizarre beliefs or whatever is like starting in school, people that are going down the different paths should start working together right then and there, because, the team in the machine shop, if you're working with them, they're going to tell you right away, like, this tolerance is just unrealistic, or why do you need to hold this tight? And if the people that are on the computers designing the parts aren't ever actually making chips, they're not going to know that. And, it's always best to go hands on. And one of my things going way back is that people should have to build their designs because that's going to be a telltale sign that, oh, yeah, I guess I didn't realize this when I was moving stuff on the screen, but I can't get to this screw, or I can't tighten this bolt. And it makes a world of difference seeing, seeing what you've done firsthand and standing there with a bigger hammer going, it still won't make it work.
Yep. Or I didn't think about this is how it's got to go together in this order. Yep. Yeah. Before I came to DS at Carl Schmidt, my guys would go out on Fridays and they would help build in the shop all day, or at least an afternoon. They would, if they were designed something that week and we were building it, they'd go out and they'd help the welder assemble it and put it together and tack it. And they would go through that whole process, or they would go work on the press brake.
Yeah.
Because it gave them then that visual ability, right? I talk about it like if you show someone a 2D print today, most people have a hard time reading a 2D print and visualizing 3D, because that's, excuse me, that's a learned skill. We don't teach that skill anymore because everything we see is 3D visual in front of us. I mean, everybody wants to be in, AR, VR land, but we still have the basic fundamentals, right? So when you start talking about designing and manufacturing, having that experience to be able to see and understand how those things are going to go together and visualize it in your head is a learned skill. If you don't ever spend time building anything, you will never have the skill set to successfully see that. And rotating a 3D CAD model around in space is awesome and cool and way better than when you and I started back in this on the board and then 2D CAD.
Yeah.
But you still have to learn the skills to be the best at the job you have, just like GD&T.
And that's why, like, just embracing and working with the team around you, because by making their life, asking them how to make their life easier is going to make you look better, because you're easier to work with, you want to learn, and you want to prevent them from having bad product, or having a bad experience.
Yep. Well, and it helps you design faster, right? So like if you talk about your journey of communicating at Metalworks and the process, and really the culture that I picked up on the times I've been out there with you is we want to move forward as a team.
Yeah.
So, I'd like for you to expand a little bit about on that, because I think Metalworks is a pretty special in that aspect of culture and building that to where everyone can talk and communicate.
And it's just a matter of that. Exactly. Being able to communicate, working with those around you, and basically making the most of other people's knowledge, sharing yours and gathering theirs. We'll have teams that get together. We do the same thing that you did at Carl Schmidt, where, there are times where we will go out and help production. I spent, I think it was a week or two, building toolboxes because it was my design and we were shorthanded. We need someone to do it. And I went out there and did it. And luckily, I was very happy with how it went together, which, I expected that because I did a lot of the work up front, talking to everyone. But just that reassurance that, yes, this does work. And that's when you're going to see ways to make it better, is when you're out there getting your hands dirty. But, have it both ways, because I have people from the shop that will call me, on regular occasion. hey, we're having problems with this. Is there something we could do? I have an idea. What if we did this? And being able to look at their idea and show them, well, we might not be able to do that, but if we did this, it might work and it might make things better for everyone. So you're really just after opening up the communication channels so that everybody feels like they're a part of it, because they are. But for me, the big thing about manufacturing has always been the ability to point at something and say, I did that.
Yeah.
It's something that goes way back to my first job in industry, where I was designing, this is how old I am, antennas for cell phones. But it was really cool to be able to be, out with some friends or something like that. And, somebody get a new phone, you grab their phone, you take a look at it, and you unscrew the antenna, take a look. Yeah, that's one of the ones that I worked on. I did that. Like the Alltech crew, they see their stuff everywhere. That's got to be the coolest thing ever. And, people see it and know them. And it's like, hey, check it out, Brad. There was an Alltech vehicle in my front yard. So I don't know. I think that's really cool.
Yeah. And it's sort of funny of,
I
all the
went all
years.
over the place.
No, all the years you and I have been doing this in our AE time, like I think that every time I see a Timty trailer or side dumper or a Load King or Trail King or Altec, or I mean, you pick a company in the Midwest and like knowing that they've used tools or we've worked with them and supported them, like that feeling of we help make something better is cool when it's something I did and I personally made it better. Like it's 100 times more than that.
Yeah.
There's a question here, and you get to answer this one first. So I'm going to get collision detection and simulating simple physics concepts like gravity would play an incredible role in how we can simulate, design, and test it more before the first prototype. Any thoughts?
Yeah, I guess I'm a little bit thrown, because you can do that. I'm a little bit thrown by it, because I use collision detection to basically make sure that everything's going to move through its paces and not collide. The simple physics like gravity, that's possible. I mean, you can do it. I'm not sure what they're after with that. Because I would just look at it as just a simulation study and put your forces on it and then add gravity.
Yeah, I think they're saying like the more you can virtualize stuff, the more accurate it's going to be when it's built. And I agree with that. I think it also comes in though too, like when we're talking about robot programming, you have to have the accurate virtualized environment to be able to test for it, right? Like
Right.
I can design up anything and I can do collision detection and yep, looks great. Yep, it fits with the case that goes over it. And then I go out to the shop to bend it and it's like, I can't physically bend that in the press brake.
Right.
So I think
there's no way to grab it or whatever.
And so I think if you look at the 30 years of SolidWorks and what's now common, to your point of like, yeah, you can do that. It's all in the software. It's baked there. I think the next frontier is taking that same ability to virtualize and verify and using software to do it in the manufacturing side. So we're not standing at the robot trying to figure out whether it can reach. We've already validated and verified that.
Yeah. And I just grabbed my controller and moved it and I saw right away. Okay.
So specifically how assemblies would interact. My question relates to how large scale assemblies say for a robot and welding. Yes, for robots and welding, yes, having the actual virtualized robot with all the kinematics is key, especially when you're talking rotaries, linear rails, things like that, to where everything has to work in concert. That is very big, being able to virtualize those components.
And you're able to see it, as you're putting it through the motions. If it's going to hit, you're going to know right away.
Yeah. And there's some things, obviously, we can't say who, but there's things that we have worked on that are like, 8, 10, 12 robots all working in concert, coming in and doing all these things and checking for collisions and movements. Like It's all possible. It's all done every day. I think the key is like if I'm a SolidWorks user or a mainstream innovation user, I now have access to that technology that 5 or 10 years ago was only available to the biggest companies with the deepest pocketbooks. Now, it is new, and there's the challenge, right, Todd? Like we've talked about before, the step one is you got to virtualize your environment and make sure that it's accurate to the real world, right?
Yeah. And I mean, that's what everything's based on, as far as setting up a press brake cell, you have to have your press brake model, you have to have your distance to your robot, you have to have where you're picking up, where you're putting down. Everything in that environment needs to be there. But as soon as it's there, that's done. And now you can put your part in and start to move it around. Um, and then I've run into the thing where I actually put in the press brake tooling because I want to know where I need to set that up when I'm creating the program. Do I need to have it down here, or can I move it over here? Can I leave it in the same place for these different parts? But, getting that foundation built has to happen before you really do anything.
Yeah. Yeah. There's just like AI, right? Everybody mentions virtual twin, but when we talk about the virtual twin, we're talking about a virtual accurate representation of the real world so we can validate and verify that it's the same. Um, Again, Mike's perspective, that's what it means to me on the manufacturing side is I have the exact representation virtually as real. So everything I test, validate over here is the exact same thing that's going to happen in the world. In the real world, I know exactly where that reach is going to be. I know where the collision is going to be. I know what the press brake is going to do. I know how all it's going to fit.
Yep.
So believe it or not, Todd, we're almost to the end of our hour already.
No.
This has been a good conversation. There's lots of great things. I do have to pay the man, if you will. So, I do want to mention we have taken a lot of things and we've put it on Spotify along with all the other SolidWorks content that's there. So if you don't just want to see us and you just want to hear us while you're in your car or on your bike, you can go to Spotify now and do that. That includes SolidWorks Live, Manufacturing Live, which is now Make It Better, right? And everything will be up there, as well as live.solidworks.com, your favorite YouTube channel. All those things will be there. So now that I've paid the man, Todd, I do want to thank you for your time. We are working on something maybe this summer, having a manufacturing day here in Nebraska, bringing in students and companies and things like that out at SCC. Lynette and Caleb are working with us on that. So hopefully, once we get more details, I'll see you out there with me. And if anybody wants to come see you and ask questions, they can.
Absolutely.
But let's talk about Metalworks. Let's say someone loves everything that you talked about today and they want to go learn more about Metalworks and maybe come work with you. What's the best place for them to go for that?
I would start with the website, and I think Ian's going to throw up the address. Hit up the website. We've got several videos up there so you can see some of our equipment in action. If you go to the About, there's a great story told by the owners that started the company, so you can get a good feel for what we do and really the sense of team and how we're all working together for a common goal. That would be the best place. You could also reach out to me on the forums, in swim community. I'm there a lot.
Yeah.
User group meetings, world, slug me. I'm around.
Yeah, I was going to say, how would people get a hold of Todd? But I think everyone knows how to get a hold of Todd. So that's why I wanted to talk about Metalworks.
Yeah. So yeah, Metalworks, hit the website. That's going to be the best. And it's going to have contact information if you want to call someone or email. But that'll also give you the best background about the company.
Cool. So as we get a little bit closer, we get the dates finalized for the manufacturing day here in Lincoln with the group and the team and all the stuff that we're going to do. We're going to talk about machining, robotics, what Todd's been going through for last year, Metalworks has been going through. We're going to talk about plant layout, virtual factory. We're going to do some SolidWorks stuff. I might dust off my training skills, Todd, from the last 15 years and do a SolidWorks class or two. So
Nice.
We'll let everyone know as that comes up. Todd will work with me to evangelize as well. But Todd, I can't thank you enough for being on today. And I think I'm going to be down at your place on Thursday, actually. So
sounds good. Thanks for having me.
Cool. Thanks, guys.